Now, as we are using psychometric chart for our load calculation, sometimes we tend to forget few trivial but very important details. Now, this data, what we are seeing is the weather data of Dhaka city, and it is being taken from ASHRAE's meteorological website. I'm sure you can go at the website and get data relevant to your project and to your city. Now, as we are looking at this table, what we find at the cooling outdoor condition at 0.4%, the dry bulb is 97.2 and mean coincident wet bulb is 78.6 degree Fahrenheit. This is okay. This is giving us the data relevant to worst outdoor condition that we are expecting, and we can use this as we are doing the cooling load calculation. But again, there is another data given here relevant to dehumidification conditions. At 0.4% probability, again, the dew point is 81.4 degree Fahrenheit and mean coincident wet bulb is 88.5 degree Fahrenheit. Now let's plot these two data, the cooling and the dehumidification, along with the desired room target air condition in the psychometric chart. Now here we have it. Three important points. This first point at the bottom is the room desired condition. And as we find it out, it's 25.85 BTU per pound of dry air, the enthalpy. Again, the red line here, this point is the dry bulb at 0.4% probability. Cooling condition, just we have seen earlier here, this one. And the blue line here and this black dot we see in here, it is actually giving us the dehumidification condition that we have just seen earlier. Here, this one. Now, as we plot all this, let's, for instance, take these 2 points first. At the desired room condition, we have 25.85 BTU per pound of dry air enthalpy at the air. And at the target outside air condition, what we have is 41.9 BTU per pound of dry air. So we can usually get the difference in enthalpy is 16.05 BTU per pound of dry air. And if we try to cool down 1000 CFM of the air, it's a pretty simple and straightforward formula. CFM multiplied with 4.5 multiplied del H, then what we have is 6 ton of cooling. Now let's look at the dehumidification condition in comparison with your target or desired room condition. The dehumidification condition, the enthalpy we find is 46.9 BTU per pound of dry air. Here at 0.4%. And if we find out the difference is around 21.05 BTU per pound of dry air, it is higher than that we have earlier. Earlier it was 16.05 BTU per pound. Now again, for 1000 CFM of air, if we apply this particular formula, CFM into 4.5 into del H, which is the humidity, the difference that we have found just now, the amount of cooling is required is 7.9 ton. Now, this is different, right? So what you're going to use in your load calculation, 6 ton or 7.9 ton, which one will be wiser? That is the call you need to make as a designer. And I think it is very simple and straightforward. We are going for 7.9 ton in this particular scenario. But if we do not compare both of the scenario and plot them in the psychometric chart, we don't have the full picture. That's why I said you earlier, this is very important and we should not overlook it